All right, these are the answers to day 20 review. And so for the first one here, we have a table with values of f prime. It says let f be a polynomial function with these derivative values. Which of the following must be true from -2 to 6? So A says the graph of f has to be concave up. Now in order to be concave up, our first derivative must be increasing. So if I look at this, the derivative went from 3 down to 1. So immediately it didn't, right? It went down. So that can't be true. The graph of f has at least 2 points of inflection. Now in order to have an inflection, again, we'd be concave up if we were increasing. We're concave down when f prime is decreasing. So whenever the derivative switches from increasing to decreasing, we have a point of inflection. Whenever it switches from decreasing to increasing, we have a point of inflection. So if you look, we see we went from 3 down to 1, back up to 4. So somewhere in here, there would have to be a point of inflection. Then we went from 4 to up to 7 and down to 5. So somewhere in here, there would have to be a point of inflection. So there has to be at least 2, and that's what B says. So we're gonna pick that one. Let's just kind of look at the rest of them. F is increasing. That would be if the derivative was always positive. And while these are positive, there's nothing that says they have to stay positive. Maybe it goes from 3 and down into the negatives and back up to 1 by here. So nothing says it has to be that way. It might, but doesn't have to be. F has no critical points. A critical point is when our derivative equals 0. And while none of these equal 0, it doesn't mean that it doesn't equal 0 somewhere in between, right? So again, maybe, but doesn't have to be. F has at least 2 extrema. That's when f prime switches from positive to negative or from negative to positive. And again, we have no visual evidence of that switching. Maybe it does, but there's nothing that guarantees it. The only thing that's guaranteed is B. For this one, we have the second derivative graph given to us, and it says the second derivative is shown from -2 to 4. What are the intervals in which the f is concave down? F is concave down when the second derivative is negative. This is the second derivative, so from -2 to -1, and from 1 to 3. From -2 to -1, 1 to 3. E is our answer there. Then we got number 8 here. Differential function has the property that f of 5 equals 3. So that's a point right there, 5, 3. And we're told that at that point, the slope is 4. So here's our slope 4. We're supposed to find an estimate for f of 4.8 using a local linear approximation. This means a tangent line. Okay, so anytime you see an approximation or a local linear, something like that, we're building a tangent line. So y minus 3 equals 4 times x minus 5. We're going to put 4.8 in for x. So y minus 3 equals 4 times 4.8 minus 5. That's a negative 0.2. And so this will give us a negative 0.8. And if I add 3 to that, we're going to get 2.2. There's our answer. All right, then we got this here. We've got 2 graphs, A of t here and B of t. We're told from 0 to 4.5 hours, water's coming into tank A by its rate, and then we were given an equation for that, and during the same time it's entering tank B, but we weren't necessarily given an equation for that. All right, the graphs of A and T are shown before. They intersect at K and at 2.416, so we'll keep that in mind. All right, how much water is in tank A at 4.5? Now that said that the tank was empty, so we don't have an initial amount to worry about. So we're only going to have the water that's come in, which is the integral from 0 to 4.5 of A of t dt. And if you do that correctly, you should get 66.532 liters. All right. There was 1 point given to you if you had the integral right, and 1 point for having the answer right. All right, B says, during this time interval from 0 to K, water flows into B at a constant rate of 20.5. So in other words, this right here is a flat line at 20.5, all right? What is the difference between the amount of water in tank A and the amount of water in tank B at time t equal K? So what we're gonna do is we're gonna find this time K first. So we should take A of t and set it equal to 20.5. When does this graph equal 20.5? And if you do that, you get K equal to 0.892040. Okay, you got 1 point for finding that value out. All right, now if I want to know the difference between tank B and tank A, what I'm going to do is I'm going to integrate the tank B, and then I'm going to integrate tank A, and I'm going to subtract the two, right? So we're going to do the integral from 0 to K, and I can either put that number in or do it like that, and we'll do B of T, which is 20.5, and if I just do that, that's going to be the whole area, the whole volume for a B, but we're going to subtract from this the integral from 0 to K of A of T. Now you can do that as separate, or you can just do M as 1. It doesn't matter, but you got 1 point for setting up that integral, or 2 integrals to do that. And then if it gave you an answer of 10.599 liters, that was a third point. So again, not too bad. We had to find that K value and then use it to figure out our answers here. All right, now C says that the area of the region bounded by the graph A of T and B of T between K and there is 14.470. So this area right here is 14.470. All right. They're asking how much water is in tank B at the end of this time 2.416. So we want to know, basically what we're looking for now is this area right in here. All right. So what we're going to do is we're going to split this. We're going to take the area from here in B, and then we're going to find the area for A between here and here and subtract this amount from that. And that will give us the area of B. So you needed to, for part C, you needed to set up an integral from 0 to K of 20.5 dt. Again, that right there is going to be the area under B from 0 to here, to that K value. All right. All right. Then we're going to add to it from K to 2.416 A of T dt. Now that area would be everything under the A, okay? But we don't want all of that. We want to take away the amount that's between them. That will give us just the B value. So we're going to subtract that amount right there. And then if we do that correctly, we should get 48.314 liters. Now you got 1 point if you had this on your paper. If you understood that you're supposed to integrate A of T from here to here, that was worth 1. And then if you were able to do all of this correctly, that was a second point. So again, not too bad. Even though it's kind of a tough problem, it was only worth 2 points. And then this says, during the time interval, the rate water flows into tank B is modeled by this equation. Is the difference increasing or decreasing at time 3.5? So what we want to do with this one, anytime you have an equation and you want to figure out whether it's increasing or decreasing, you're talking about its derivative. So what you want to do is you want to take the derivative of W minus the derivative of A, and you want to see what's going on there. So if you do this on a calculator, you should have gotten negative 1.14298, which is less than 0. So if you found that, that was a point. And because our derivative is negative, we would say that the difference is decreasing. And if you said that, we get another point.